their weight down. Now, the bariatric surgery evidence suggests that gut signals from the intestine may actually influence that set point. But please remember that if you have gastric bypass, you're producing extremely unusual, non-physiological changes in gut secretions. And we think that that's part of the system for shutting down intake. So at the moment, we don't have evidence that your brain can adapt back. And the animal evidence suggests that we grow receptors and other connections in our brain, which effectively mean that we prefer to be fat.
Thank you. Any other questions? If not, can I ask? Can I ask you a question?
I want to ask him a question.
Okay, you do that first.
No.
Okay, can I ask you a question? What the message I got from part of your talk was that actually, if you're obese as a child, you're way away from the normal physiology, much worse situation, because you wouldn't expect them to be that obese than as an adult. And is that the right? I mean, you exceeded your normal physiology, way out of control.
Yeah. So I'm suggesting that the evidence is that if you're an obese child, your intake is much higher than that of a normal child. And we used to think that you just big fat, and you only need 5 or 10 calories a day extra to make you fat. It's not true because of the normal increase in lean tissues as you grow, and the extra lean tissues because you've got fat. So actually that's a big problem.
Yeah, no, that's a very important point, I think. I think that because one of the biggest changes in obesity has been the increase in childhood obesity. I mean, that just shows. Do you want to ask your question?
I'd like to ask my colleague. Beautiful analyses of genetics. And I've been fascinated by genetics. But unless you're dealing with major genetic effects, you talked about 1,600 genes being linked to obesity. And you chose this beautiful study where there was a 3 kilogram difference, particularly if you're on a high-fat diet. But if you look at twin studies, there's powerful evidence of really important genetic effects. Why can't you show with all your genes studies the same big effect of genes? Although you have beautiful studies, you show very little effect on body weight, and I would normally expect it to be much bigger.
So the effect of the 3 kilograms was not seen in the high-fat diet. It was seen the association with the FTO, basically.
But why wasn't it not 3 kilograms, but 30 kilograms?
Well, again, one of the reasons with the inconsistency is measuring these these environmental factors. So how do we measure physical activity, for a fact? How do we measure food intake? So this is one of the reasons that we're finding these inconsistent results, is that we don't have a consistent way of measuring these different inputs and outputs. So some of these variations that we're seeing is because of that. And that's maybe one of the reasons why we can't see there's inconsistent results.
I think that there's another potential effect, which means that your work is even more important. And what we're discovering is, I run think tanks in Stockholm with the Nobel Prize winners on genetics, okay? So I'm having to be educated, and I'm learning slowly. And when you take the genes for heart disease, for diabetes, for obesity, and you find all these beautiful studies, they only account usually for 5 or 10% of the effect that you would expect. And the evidence looks as though the genes that we used to think of as junk junk DNA. It didn't do anything, it was just stupid. It was left over. It was not important. It now looks as though it's extremely important, operating through the microRNA, which a microRNA is the big, fabulous new stuff. And it works by changing the effect of a message to produce the gene in the first place in terms of its effects.
So affecting the translation process as well, so basically. That's what
so the gene story is becoming more and more complicated, and it's not just one step of whether you got the gene, but what controls that gene, and what controls the control gene, and the control gene controls itself and also stimulates another gene that does the opposite effect. It's getting incredibly complicated.
That's true.
Yeah, I think that's a very important point. I think expression of genes, that's basically what it comes down to, whether there's super control mechanisms. That could explain a large part of genes. Any other questions? Shall I stop? Well, thank you very much. I'd just like to thank both speakers for excellent talks.
There's still so much to be done.
And I think it's lunch now, is that right?
Yeah, by ending this session, we finish actually, except for those who will have a workshop.